topics that we had actually in the past days are how do we go from does this work when you have a product ID to now we ship at scale. And this is what we've been discussing both in terms of feasibility, but also in how to implement mass production. And the first thing I want to ask is if you could actually introduce yourself.
Okay, my name is Mark. I'm co-founder of Pilotfish together with Harm, who's also here. And my background is designer, studied in Lemberg in France. And so as a designer, we started Pilotfish. And there was one thing that was always fascinating is actually the part that comes after the design. And also it's very fulfilling as a designer to see the product getting real. And since we worked a lot in Taiwan, we had our first office in Taiwan, we had access to manufacturing. So we had first customers asking us, can you maybe also manufacture this product? And we say, oh, sure, we can do. It's very easy. We have tooling around the corner. So we stepped firstly in 2000, 25 years ago, quite naively into production. And so we learned it in that sense the hard way. So from actually having a technical drawing that wasn't even having tolerances, to have a tool that really wasn't matching the tolerances.
Makes sense.
Yeah, and my role in the company is obviously as an owner, you're busy with enabling new projects coming in, and that's maybe also sometimes where problems could arise because you're under like a financial framework. You actually want to start the project, and then of course you want to proceed, you want to get it started.
I pass it to Daniel.
Hi everyone, my name is Daniel Lassodelli. I'm a senior innovation manager at Pilotfish. My background is also industrial design. I studied at TU Delft in the Netherlands, where I already started specializing on medical devices, and I work for Pilotfish since 6.5 years. And my role is basically I'm the medical device development lead within the company. I also helped to co-author our 13485 based quality management system together with Maeva, and I'm also the lead for human factors efforts within the company. And basically as innovation manager, my role is from idea to mass manufacturing to deliver the product and to ensure that it's a smooth process in the beginning, ensuring that the client input is translated into the requirements and to a product vision, and then along figuring out the scale of an appropriate process related to this design vision, and along the journey to ensure that we follow the design vision and that we really tackle the things that we have to during the process, interfacing with external partners in the development, leading the teams and guarding the design vision along the journey all the way until mass manufacturing, basically. So that's more or less my scope.
Thank you.
My name is Lou. I work as CTO at Lemberg Solutions. We are a software and hardware service company. We started as a company that provided some web development. After that, our services extended for mobile. Then we wanted to deal with more complicated projects, and we started to look into the firmware. At some point of time also we saw that what potentially could be a specialization where we can bring more value is to add some data science to the stuff we do. And at some point also we started to deal with hardware development. So my area of responsibility more process setup, sometimes to oversee some projects. Maybe favorite part of this is to do some field tests to see how technologies that we really developed for a long time work and bring value.
Yeah. Hello everyone. So my name is Pavlo Mateshin. I'm head of embedded development at Lemberg Solution. So I oversee like teams of our in-house teams, like for electronics engineering, mechanical design, and software development. So my main responsibility is like manage our teams make sure that they're like developing the product, the software, the electronics in a like right way, and in the end we will have the product that was requested from our customer.
Thank you for the reintroduction and introduction. I think it's really nice because we have here people that are from the industrial design world down to firmware, mechanical engineering, and everybody has had a link with manufacturing as well. So I think it's interesting to see actually from your specific words, like where you evolve mostly, what do you think is actually a truly feasible concept? How does a truly feasible concept look like from your perspective? And I know it's a bit of a philosophical question, but just to start it and see what's to your mind.
I can start. So there's this basic framework of defining feasibility as feasibility from user, technology, and business perspective. And essentially, this is what I believe is very important to early on tackle, and to really tackle all three. You often have companies which are, let's say, technology push, and then they full-on focus on technological feasibility and can talk about the core technology or the production-related things, but then they don't focus enough on the business case, and they have no idea how this will be delivered to the clients in a feasible business model, or they don't know enough about the user. And the same goes for companies that lack expertise in all these three. So what I often see is the problem is when one of these is missing.
Yeah, so one of the famous triptych is missing indeed. So truly feasible means from the user perspective, technically, and as a business.
Yes.
Are there other insights around that?
Yes, we had the cases when we had to answer the question how a specific task could be done at all, whether it is possible to do by technology. For example, if you have a camera, can you evaluate some vitals on an object? After that, how that could be done, from which point, how you should place a camera, for example. And after, what would be the accuracy, whether it is possible to have this done with a good performance, so you don't have to wait half a day to complete the calculation. And after that, whether it is legal at all to do this kind of stuff. So after investing so much money, finally you are not allowed to use this technology, for example, in European Union.
So do you think that is also very important to do like any legal research, regulation research early on? Is that something that is advised from your perspective?
Exactly. We had some cases when we had a good concept, but after that, because it analyzes faces or behavior, so still you are not allowed to use it in at business, so this concept has to be rejected.
Okay. Do you have any insights related to that, Mark or Danny?
Not exactly to that.
Go ahead.
Actually, I think what is important, especially for startups, is that you are aware of how your investment stream is going. So, because the moment you go into production, you will face investment, not only for tooling, but you also face investment to, let's say, finance your first production batch, because no manufacturer starts without having a 50% payment received. So that means it's very important, so we can lay that out. So not only how much you have to have in total, but actually at what specific moment you need to have it. Another aspect, and I think Daniel mentioned it a little bit already, is the use case should be solid. And we work a lot with startups, but even with bigger companies, we got a crazy request sometimes that create specifications that are very, very much. The famous example is a reader similar to your pick weight device that had a specification to be so solid that you could throw it out of a truck. And we didn't understand why. Actually, it was very difficult to why would that device need to be falling out of a truck. After a lot of questions and a lot of calls and meetings, the answer was actually that the users are so frustrated with the device that they throw it out of the truck. So this is actually something that we've learned, but only it was obvious. But still, you get requirements that make the product 3 times less expensive, because it had to be ultra rugged, had to be waterproof where it didn't have to be so waterproof. And I think this use case, user understanding, to know this good is very important, but also the use case is really important.
So if I summarize, we have the triptych. I'm going to call it the triptych. The user, the technology, the business. We also have to keep in mind the legal and compliant aspect, even in the feasibility phase, and also question the requirements and understand if they are actually the real requirements to solve the problem, or if we can actually reframe some parts of that to actually make a product that makes sense.
And the point of Mark on the investment, so the financial feasibility of not just the product and the use case, but the company itself towards development, which is very often not underestimated. Budgets are extremely underestimated in startups because everything is very simple until you have to do it and understand the complexity of the most simple thing.
So also take into account the coming investment to actually scale it. Okay, I wanted to ask a little bit questions also around like secure development and human factors, because we had some presentation yesterday actually in that direction. And I wanted to explore how actually security, human factors can be embedded earlier in the development to avoid impeding the process later. One of my main questions is, how do you build this consideration in from the start without slowing the process in a way? And I'm talking both about security, cybersecurity, human factor.
Yes, well, I will try to answer this question partially. So usually, like we work a lot with the product requirements, and it's really often that the security and the human factor engineering are something that people like save for last. But yeah, but in general, what you need to do is like to have some basis of it. So you need to consider that eventually you will need to have the security because of some, I don't know, some regulations of, or you need to have some functionality on your product that is, you need to have it. And if you have these requirements considered on the start of the project and you have it somewhere in your mind and your team consider some kind of functionality, it will not be so difficult to like implement it in the project because usually you have like a prototype, you build it and we forgot something. And it was like sometimes it's really important and it takes a lot of time, for instance, to integrate this security. You have to, for instance, add a lot of additional code in your firmware. This code doesn't fit to the firmware anymore, and you need to take like another MCU, but you got the MCU, the biggest one with the biggest memory, so you need to change your hardware design, or you forgot to, I don't know, place something really important, some button or something in your design, and it's like critical and requires a redesigned solution. So in general, what you need to do is you need to write down these requirements in some sheet, and whenever you reading these requirements, you see that okay, I have a security, I need to remember about it, or okay, I have like my device have to, I don't know, be ergonomic, easy to use, and I also need to like consider it during the mechanical engineering or software development or electronics engineering. Yeah.
So have it in the requirement list for sure, and having teams aware of this aspect, even if it's at a phase of the project where it's not the central focus somehow. Okay. Daniel, for human factors.
Well, I think what is critical to understand, for like circling back to your question, without slowing down the process, right, is that start to walk towards the wrong direction will not get you to where you want to be. So, and then figuring out how the hell to get to where you actually wanted to go will take you much longer. So the question is not how long it takes, but how much time do you save in case you made any mistake in your assumptions of your product direction. So with human factors, your first step is user needs. And if that's not properly assessed upfront, then you will end up developing a product in the wrong direction, and the whole thing is screwed. And the same goes for the next steps afterwards with the user testing. In medical device development for human factors engineering, that can be quite costly because you have to go to hospitals, schedule with the nurses, they have to be available, take some time, you need prototyping, you need proper protocols, and it takes time and everything. It's expensive, but the money that you can save by understanding what risks are there and how to actually make a user-friendly product that, I don't know, that is not full of alarms that users just deactivate or go crazy from, it's very valuable, and it's close to impossible to develop a great product without a good foundation.
And it's often when it comes to cybersecurity or human factors, the teams that actually collect the insights and the observation or the requirements are different than all the teams that need to implement actually in the product. And what do you think are like practices, or maybe it's even cultural habits that ensure that these perspectives that you collect are actually truly integrated from the requirement through to implementation technically in the product?
Maybe I will have a little bit opposite comment from the good practice. For instance, when we started developing the technology to visually evaluate the animal, so the initial goal would be whether it is possible at all to have this technology. So the main focus for this couple of years was please create the technology that provides good accuracy, good performance. So now when we have it, and about security nobody didn't think at all. Now when we have it in place, so we have a question, where should this algorithm be running? Is it on premises, on the device, with a lot of protection, which potentially would be redundant in some way, or we need to have it to be run on a cloud, so we would have this algorithm be completely protected. But still, when you talk about the field test where it would be running, at the farm there are no internet connectivity at all. So always stuff had to be considered how this algorithm should be protected, and maybe it should be a little bit divided. Maybe some parts should be run locally, and maybe it should be run with some delay, because you do a photo shoot of every animal, and maybe you need to have the result of this video capture somewhere, maybe in the evening after end of the shift. So this is the idea.
Yeah, and on my side, maybe to add on how to ensure that basically the insights are implemented by other teams, is I think it's really important to understand that documentations within projects are communicational tools primarily. They are also nice for getting things certified and proving that you actually did your homework as a product developer, but primarily they need to serve for communicating to other teams, and you will have other teams because most products these days are fairly complex, so it's really difficult to Da Vinci the hell out of it. You need to figure out how do you ensure that your insights are actually implemented by the other teams, and you need follow-ups, and you need people to review each other's work and to communicate it about it. So you need sessions to cross-pollinate and to involve your different, let's say, team. If it's about cybersecurity, then the team who's an expert needs to talk with the people who are thinking about industrial design and usability, because otherwise they will come up with things that are ridiculous for you, probably, in terms of cybersecurity, because this is not their mindset. And everybody has their different mindsets, and product is strong if those are combined in a fruitful way.
Yeah, so both have the observation also come to the technical team and also document in the right way to communicate between teams, I think is important. We had some talks today specifically around manufacturing and scaling up also. And I wanted to come back to that and spend a bit of time on this topic. And we looked today with Pablo Lu in my presentation on how to have a transition from development to production in a smooth way and focus on having less risk and have a good supplier collaboration that brings the product together. And I wanted to ask, what do you think are some non-negotiable checkpoints before you hand over to manufacturing, actually? The chickpeas.
Yeah. I think one of the points looking from, let's say, housing or dimension is that the electronic hardware is final in the form factor, and software is always a bit more flexible, as we heard, as we also know. We cannot have a battery change after tooling. So actually this is something, and it is important that whoever runs the project is signing it off, so to really make sure that there's no change. I think this is one of the key points in that. From the point of making a housing and starting a tooling, for example. And
from your side, Pablo, do you have any non-negotiables?
For sure, you need to test really thoroughly your prototype before handling it for manufacturing. So when you have your MVP or prototype, which is final for you, before passing it to manufacturing, you should make sure that it will be a final one. Yeah, so it's really simple, but sometimes people do the product, build the prototype, and not do the thorough testing and think that okay, we can manufacture it. But in fact, when the product is passed to user, it is passed to some, I don't know, another persons then have tested it, and people start to see that something is wrong with it, and yeah, so it's better to test it thoroughly and finalize it and be sure that you will not change, for instance, enclosure. You will not change, a battery size or something else. Yeah, otherwise it requires really big amount of investing to change something in manufacturing. Also, probably before handling it to production, it's good to ask them opinion on what in their if you have a factory, you can send them some files in advance and ask whether it is good good enclosure, or it's they would be able to manufacture it properly. Yeah, so it's a good way to have design for manufacturing phase. Yeah, so you tightly work with the factory and they help you to design to say a proper device for manufacturing. because sometimes to have a good price, you need to, for instance, make sure your product will be assembled in an assembly line for, I don't know, X seconds, for instance, 30 seconds. And if you have like complicated design, it might not be possible. Or they should need to have some special tooling for the assembly or some other cases. So it's, yeah, to answer this question, it's, yeah, first of all, you need to test your product and make sure that it's the final one, and work tightly with your factory and like ask their opinion, what could be adjusted, what they need to smoothly manufacture your device.
And maybe just to add what you said, Paolo, because I absolutely agree with that. How you figure out if this is your final product or not. What we often do is that when we build the list of requirements, we basically make a verification plan where we stage it. Which requirements do we verify at what stage? Because let's say usability requirements you have to do early on because your product is very fluid at that point and you have to make sure that it's the right product. Drop tests you obviously cannot do at this stage because it's not engineered yet. So you figure out for each requirement at what stage do you do, and then if you think like this, you'll figure out what are those requirements that you can test before production and what are the requirements that you can test only after production. And then basically this way you kind of figure out for yourself a list of things that you have to prove and test and verify on in order to say, okay, now the product is ready for the production. So that's a bit how we often think about figuring out if the product is ready or not.
Yeah, so make a big difference between what should be verified and locked before tooling, like Mark mentioned, like the electronics, like we can't change battery and so on, and what can be still potentially or needs to be only verified with the tool parts, which happens, and lower the risk with that. And as you mentioned, also include the manufacturer in the discussions, because they can also identify something that you think is locked in the design that is actually not good and will create like higher cost later. So I think that makes sense. My question is then, after we've done that, we've locked the design, we're tooling, we're producing, and we need to put in place like a quality assessment process, which we discussed earlier in our presentation. And you need to put that in place with your manufacturing partner. How do you do that? How do you accept your goods from a factory? Can you walk us a little bit through that for someone who has never done that, actually?
I usually come to you, so now I hand over this to someone who's more knowledgeable.
I think Mark can answer.
Yeah, setting up the production basically means, of course, you obviously visit and sit together with the company who is assigned. I think typically stuff comes in, so it's everything, there might be consigned parts, maybe the customer sending you a chipset, like the famous, what was it, NFC board we heard today. We also know this story, same issues. And then you would actually define, okay, what's coming in is approved and checked, and then you build the process. You look over the shoulder of the people, what the people are capable of. There's some crazy things like crazy gluing stuff for waterproofness and so on. These things are, I think, have to be handled with extreme care because that's where stuff goes wrong. And you try to identify the critical points, and on these you put extra attention, and then you observe the process within a pilot where you see, okay, what fails in this pilot, and from there you learn and enhance, and then you have a proper like error check, and then they actually bring back into the process method to make sure that whatever happens or whatever's discovered is happening, not happening twice.
Any other advice on how to do that for the first time and accept your goods the first time?
I don't know whether this is for the first time, but for the case when you have the package already completely assembled, and I mentioned this in the session today, would be good to have 1 or 2 inspectors that can come to the factory to take the box, to take out the devices that you produced, and to have a nice list what should be checked. So everything should be done in a random way. Still there is a procedure how that should be implemented. And again, depending on the class of the device, you need to accept certain % of issues. So only after you can accept the work from the factory, and still you need to know that there are no relationship between this inspector and the factory, because very often there are. So you would have very independent report, and you can make decision whether you take the goods or not.
Very good point, yes.
Yeah, so I would like to add that like before setting up the mass manufacturing, it's a good to ask your supplier to give you some like thoughts or some list what will be the quality assurance checks. So how the device will be like tested, for instance, whether they have some automatic circuit testing or some assembly, I don't know, some testing after assembly. It might be visual testing, or some maybe it should be the test firmware. For some cases, test firmware might be a good option. So after device is manufactured, the vendor flashes the test firmware and they run some tests. For instance, maybe you have seen like to like get some color patterns on some screens, yeah, do some touch sensor testing. So it's all made in the test firmware. So in general, so you need to, together with the manufacturer, you need to have some quality assurance test strategy. So it's really important because it will decrease the amount of failed devices, yeah. And the cost for their repairing and maybe some returns. Yeah, so this test strategy is if your factory does not have any, you need to like came up with some of your ideas. Maybe it will be a testing firmware, maybe it be some test jigs for electronics testing, maybe it be something else. But you need to keep in mind that the quality of your product, it will be depending on your testing strategy.
Yes, I think you touched upon a number of points. I think also a very good point about sending someone to sample and look at the product is very important. And also sometimes for a startup, going yourself, because the price of the flight compared to the return of the products is usually less. So I think it's good to just go on that flight and try to check your first production, and if possible have someone that knows how to check also. I think those are very good insights indeed, and making sure that you can actually reduce the number of failures early is also important. I have a question that is asked maybe at every panel and in every room in the past few years, which is, with this development process from feasibility down to locking the design, down to manufacturing, right now we have a lot of AI tools appearing. How has that impacted your work? And I think maybe I want to ask specifically first Lou and Pablo, because you are in the world where you develop also software and firmware. And I'm just curious to know how it has impacted your development, your verification, your documentation. And yeah, if you have some insights on it.
I think today with development of AI tools, which could be used at any stage of project development, you may have a request from the customer. Well, today we have these AI tools. Maybe there is some change to the attitude, how they could be evaluated. Maybe the costs are different. maybe you are doing the work a little bit quicker, so maybe the efforts are much more smaller or something like this. Maybe you can at all fire all the team and have all the AI tools that will provide you all development. So I think there are a lot of these requests. Still, it is, I think, important to have some policy that defines how at the company you would use the AI tools, whether it is possible at all to share with a specific tool the code base, because you don't know actually where this code would fly, especially if you do very sensitive algorithm development. So all this stuff should be shared and explained to the team, what you are allowed to do, what you are not. I would say by default, no code sharing if you didn't do a check of your development environment to the cloud. I don't know where the environment could share this. So still it should be a very sensitive, accurate approach. We are not a product company, so we don't have like a general requirement of AI tools for every project. So we have this tool set different for every customer, and also we have to agree this. And if we talk about the team is also explained how these AI tools could be used, what activities could be improved by the AI tools. And of course, after that, it should be definitely reviewed and checked what parts this AI generated, whether it is possible, is it safe to reuse it at all. So you need not trust this stuff right now, I would say.
That is very relatable also on our side. When you think about medical device development, I don't know if you think about medical device development at all, you probably think a bit about documentation, which is very burdensome. So there's, of course, a huge potential in using AI tools to improve how easily you translate certain types of documentations into other types of documentations. And this is very interesting for us, and this is something that we have started looking into. But of course, you come and arrive to the question, do you want to train commercially available tools for that? And here you arrive to something that is more precise knowledge, not so much there on the internet everywhere, because when it comes to like risk management, the devil is in the details. So you will not train ChatGPT from what's there on the internet on best practices properly. So then it's about the knowledge base of your company of how to do that. And then the question comes up, do you want to develop your own tool, or you want to use some of these commercial tools and say, at a certain point someone will anyway teach it, so why not? So yeah, I think we are at that point of this, and we are after some semi-successful trials of implementing this, but it's definitely something that, if done properly, has a huge potential. But as you mentioned, it's definitely not at the point where I would trust it.
And when it comes to visualizing product, now you can just put a prompt somewhere and have a nice picture come out. How has that impacted your work?
Yeah, it's of course extreme at the beginning. So we actually, before design, we have a lot of companies coming to us. They already have everything finished. So there's a visualization. I think it went to a level where we had also specifications all done by AI. It's very visible, but it should be transparent. I think that's important to handle these things in a transparent way, and it's everybody should use this. It's good. But it's also making assumptions that might not be right, because these things are visualized, it looks very finished, and maybe that creates the feeling that that the work is already done, similar to what you said, so it must be now finished and we can go fast. That is not really working, and I think you still need to understand that there's a process in front of you to do.
Thank you for sharing. So I have a last question before I open it to the Q&A. I wanted to ask you, because we have all developed products for a few years, and I think we all have our project failures, and we all have recovered from them, and learned and implemented some processes. So, because we do so many different projects and products in a short amount of time, I think it's interesting because we get these learnings very fast compared to one company doing one product for a long time. What would be for each of you your concise story of failure in a project, how you recovered with the team, and how you actually change a process in the product development? Tough question.
Maybe I will reference to this favorite big example. So I think this is a good example when you didn't know how to manage actually a project that is a research, that every stage is a research, and you need to plan a little bit different these sprints. So not with what you are trying to achieve, but what would be the goals of the research. And after that, correct the next goals based on the results. Not to be upset too much, because still everything is new, and maybe to make smaller iteration without less scope, not to cover all the use cases or all the edge cases. Just always go with a positive, perfect scenario. So if you achieve this perfect scenario, this is a good result of this iteration, of this sprint. So I think that this insight is very valuable.
Thank you for sharing.
Yeah, I have a very simple and stupid example. It's actually, we specified in design in our CMF file parts to be matte, and we got it produced in China, and the parts always turned out to be shiny. And that was so annoying, so that we started to dive into that. And what we found out is that actually there's no proper word in Chinese to differentiate between matte and shiny. So actually we came up then with our own samples, because there's no samples really existing for that, to have actually a sample book with different grades of from matte to shiny surfaces. And it's a very stupid example, but it was so expensive, it was so costly, so annoying for everybody, that and we built our own tools to fix it. So in the end,
Like the apple white also, right?
yeah, apple white is another interesting one. So also the color white is also, there's no definition for certain whites. Well, it wasn't. Now it is, of course.
Maybe on my side, just to underline a point, my previous point on understanding user needs. Recently worked on a smart eyewear which enables thermal vision for users. And something that happened in that project was that basically the client was very convinced that they understand the user needs, even though they weren't really sure who would be the user, but they had a strong idea that they wouldn't want us to support in that. They want to just provide the input to us. And essentially it's smart glasses, and there's a thermal camera in it, and then with that you can actually see your environment with thermal vision. And with these glasses, basically, because it enables a special, like a superhuman vision, field of view is very important. However, they ended up early on deciding to use a waveguide, which comes with a lens, off the shelf. And due to that, we ended up with a relatively small field of view in the product, for a product that is meant to really enable your vision. And that was the moment we realized that we have a very small field of view. It was already a very mature stage, and then changing the waveguide was very difficult. So we really had to go creative on how can we solve the problem, and how can we ensure that the users will, to maximize basically the field of view of the users, because otherwise you have great binoculars on your head.
Yes. So our one funny story from our life was, and our project was, that we did some keyboard with a backlight, and previous version, the PCB was with a white silk screen. And we, for some reason, did not document this requirement and manufactured a regular board and well-known green PCB. And in the end, it was a funny story because the users started to complain that the backlight brightness is too low. And we started to investigate why it is too low. And we saw that the previous version was painted in white and it reflected more light from the LEDs. And it was it was a really stupid mistake, but yeah, sometimes you don't see like some small requirement, but your user will see it, will notice it. Yeah. Yes, so.
Thank you for sharing the stories and the vulnerable stories of also the failure that can happen. I think that's what I had as questions to you, and all these people have been presenting and talking for 2 days. I want to open the floor for question and answers. I think I will walk around with this microphone and leave you here. Does anyone have a question in the audience? Yes. Oh, I'm gonna have to climb up there. Let's go. It's my sport time.
Thank you. We heard a lot about standardization and processes and how to avoid. There's a method which is called fail better. And I'm wondering if you also try to use it, because it's very interesting in a certain frame to allow failure to happen, because you have a faster learning. And I was wondering if that's also something in your product development mind.
Maybe I can answer this one. And it's also related to another story that I wanted to mention, which is more our engineering and production team is in Taiwan, and they have a very different mindset on engineering and product development compared to Europe, because what happens, they work in a very empirical way. So instead of, let's say, doing a lot of calculations, doing a lot of simulations up front and then starting to prototype, they start prototyping earlier on. They prototype quite quick and quite cheap, and then they try to break it in all kind of ways, and then they figure out what to improve, and basically they learn how to build better products through this process. And then a failure that we often have related to this are clients who are European or from America, and they want to enforce their own process on the Taiwanese team, and then we have to deliver all the calculations and all the simulations, slow down the process, and end up with the prototypes later. And then it took me, for example, personally, some time to understand that I should not allow our team to be derailed by different expectations, but that we need to enable them to work the way they are used to work, for them to really shine and do things properly. So in a way, we implement this, and we also had issues related, but essentially, I think we also have great results through them.
Yes, maybe I will add also here. Still, besides that you have some processes or some rules how something should be done, there are always people in the team who will do it their own way with their own ideas. So I think if somebody wants to try something unusual, still we have a lot of people who will do this, but this process setup anyway would prevent you from very common stupid mistakes that we don't want actually to have on majority of the projects. So that's why this process, this discipline part covers some fundamentals, just not to avoid. And we also have this part, as you mentioned, that very often customers want to talk directly with engineers, and we ask usually to do the stocks, to provide the stocks in the public channels, like in a Slack, no private communication. So, for example, project manager is aware what engineer was asked to do, and which is beyond the planned timeline. So this example when we may have some issues that we want to avoid, and if they follow the rules, I think the result would be more predictable.
Yeah, so Lemberg Solution is like engineering company, and you guys like focusing more on industrial design and manufacturing. Let's imagine I want to build a product like with services of both companies. Yeah, I want to involve some vendor like from software part of things, and also like then manufacture it further and do some industrial design. How do I manage like what do I need to do to make sure that both sides understand each other pretty well and like communicate well, and also what to keep in mind or how to manage both vendors to make sure that they will take care of my product, and engineers will like, you know, understand what industrial designers need to know, and vice versa.
I think in these kind of projects where you have a couple of vendors involved, it's good to have one lead to define that. It's useful to make the lead the company who has the biggest share in the project. And then it's good to have shared documents so that you use the same documents. And then, well, of course, you cannot align everything, but you have some common documents. For example, performance testing, they are shared. And of course, there's different requirements for electronics and software, but that there is like a common kind of language that is established.
Maybe I will also provide comments from what we already shared. Usually it should be one single lead who would actually confirm or sign off all the decisions. So we don't have like two parts decide the same thing. So should be somebody accountable, somebody responsible. Even in our projects, we don't allow to have this kind of democracy. So it should be a clear person who would decide. So in this case, I think everything would be under control.
Yeah, so as Lemberg mentioned, we have like technical lead, and like in terms of cooperation between the companies, we for sure should have like some outlines, zone of responsibility of each part. It's really important to know that like you are responsible for a design, for instance. We are responsible for the software development, and like we don't do any decision like for your part, and you don't do any decision for our part. Yeah, so it's like this well-defined zones of responsibility. It's like a key to success, and we also usually our rule is for the tech lead that who has the most the bigger part of the project will lead in it. So in terms of like the same as you said, so who has the most part, it should drive the another parties. Yeah.
Maybe the only thing to add to that is that it's good to enable or provide some time in the beginning of the project where you define the product together, and where you work together very closely in figuring out the use case, the technological requirements, and all the key challenges in the project. And during this period also spend time to figure out together how do we work together, what are our communicational channels, what are our documentational handovers, what are our timelines, and to really make sure that these parties work together. Best, of course, is if you already have established partnership where you have done this before, and then it's easy to work with such a company. and you don't have to start from scratch.
I think we're coming close to time, but I think we can take one more question.
It's related. It's related to this. You've talked about a very complex processes and the whole development process. It's very complex. What kind of tools do you actually use to manage all the communication, documentation of every step of what you do?
Where on our side, we should use an EQMS, which we are currently not using, but I think that's the next step in us. For those who don't know, it's a centralized documentation registry that helps you in medical device projects to help to centralize the documentation and to do it in a more connected way and in a way that it's easier to trace what has been done and who has reviewed what, etc. In other terms, what do we use? We use a lot of brain power of people who lead these projects so that they are aware of things and that you have someone in the project who's aware of most of the details, or you have very clearly allocated who's aware of what details, and those people commonly sync so that things don't start to shift away from each other.
I don't want to do any advertisement, but anyway, you would use Jira. You would use, if you use Google Workspace, probably Google Drive, and all the Google related, like Google Calendar or something. For communication, probably Slack. I assume that everybody using this. And after that, depending on which technology you are going to develop, I think your technical team will select what tools they would use for development. But still, that should be a single tool set, so not to have like this chaos of different tools, because after that it would be not manageable actually to handle this properly, especially access control. Then people are onboarding or offboarding from the project, so you need to control this stuff also.
And also I would like to add that it is a good tone to use regular templates. So actually for each project we have like in our company we have standardized folder with all the necessary like documentation for the project, and when we create a new project, the project manager sees it. Okay, I have this set of documents, he has the checklist, and he just knows that these documents should be filled and during the project or on the start of the project, and it's really easy to track everything. If you have a checklist and you just review this checklist and see that, okay, I have this document created, but we need to create like some like any other documents. Yeah. So like regular templates are also okay.
Yes, I think we're coming close to time now. I wanted to first thank all the panelists for joining and for also presenting over the past days. It's been super insightful, and I think it covered a lot from feasibility down to manufacturing, from feasibility from different aspects, always thinking of the user, the technology, the business behind it, but not forgetting the compliant part, down to manufacturing, where there are a lot of little advice that I don't even know how to summarize right now, but it include like looking at how you test on your assembly line, how you actually accept your goods, when you actually lock your design. And if you have more questions, I think you can find all these people on LinkedIn or just after the presentation also to continue. Yeah, that's, I think, where I land today. It was not the most diverse panel, but I had the biggest chair, so I'm very happy. Thank you, everybody.